Hi, guys, and welcome back, data enthusiasts. In today's episode, we will explore how to create and optimize neural networks using Python and Keras for regression tasks. So, along the way, we will discuss essential techniques like data normalization, model evaluation, and regularization to prevent overfitting. So, let's dive right into it. Okay, so neural network can be incredibly powerful for solving regression problems where we predict continuous outcomes. For example, you are predicting house prices based on features like location, size, and condition. So, here neural networks can help capture complex relationships between these variables. We will use a simple dataset to demonstrate building and optimizing a regression model. Now, first we generating the sample data and then normalizing it. Generating sample data and normalization. So first we need data. For simplicity, we will generate synthetic data using make underscore regression. Then we will normalize it using standard scalar, which is a crucial step for faster and more stable training of neural network. So first we import our necessary libraries. The first one is import numpy as np. The second one is from as a tensorflow dot keras dot models import sequential. Okay, now the next one is from tensorflow dot keras dot layers import dense dropout. Okay, the next one is from TensorFlow dot Keras dot optimizer import Adam. Okay, now next from sklearn dot datasets import make underscore regression. Okay, the next one is from sklearn dot model selection import train test split. And the last one is sklearn dot pre processing import standard scalar. Okay, now generate a simple regressor data. So for this we declare a variable x y equal to make underscore regression. Now pass the arguments and underscore how many samples, 500. Now number of features, which is 5, and noise equal to 0.1. Okay, and the random state is, which is 42. Okay, now split data into training and testing sets. So the first one is x underscore train, then the next one is x test, same with the y train, y test. So equal to train test split. Now get the arguments test size is 0.2 and the random state is equal to 42. Now after this, normalize the data. So for this, we use the scalar, which is equal to standard scalar. Now x underscore train equal to scalar dot fit transform. Now pass the argument, which is a x train, and the last one is y train equal to scalar dot fit transform, which is x underscore test. Okay, so always normalize your data to ensure features have similar scales, which helps the model coverage faster. Now run this cell. Okay, where? Okay, so it's a single A. Now again run. Okay, so got an unexpected keyword, argument, and sample. It's a sample, it's not a sample. Okay, so the code is working. Now let's define a simple neural network with two hidden layers using Keras sequential API. So write this code in the new cell. So define the neural network model. So model equal to sequential. Okay, so the first one is dense 64, input underscore dimension equal to x train dot shape, which is 1, and activation method is relu. Okay, now the second one is again dense. So for this 32, activation method is relu. Okay, now the third one is dense 1. So which is this one is output layer for regression. Okay, now compile the model. So model dot compile optimizer equal to Adam learning rate, which is equal to 0.01. Okay, after this loss equal to mean QUARED error squared error. Now display the summary. Okay, so for this we use the model dot summary. Now run the code. Okay, invalid syntax, maybe you meant this or this instead of online 4. Okay, here we get an error. Now here you can see layer type dense 9, 10, 11, and output shape is 64, 32, and 1, and parameters 384, 2080, and 33. So here we use the ReLU activation function to introduce non-linearity and Adam optimizer for efficient training. Okay, so the fourth step is training and evaluating the model. So we will train the model for 50 epochs with the validation split and then evaluate its performance on test data. So we write this code in the new cell, train the model. So history equal to model dot fit. Now x underscore train, y underscore train, chs equal to 50, validation split equal to 0.1. Now what should be the batch size, which is equal to 10, verbose equal to 1. Okay, now evaluate the model on the test data. So for this test underscore loss equal to model dot evaluate x underscore test, y underscore test. And now print, which is a formatted string. So test loss, test underscore loss. Okay, again we get an error. Data coordinality is ambiguous. Make sure all arrays contain the same number of complex samples. X size 360, Y size 100. So epochs, which is 50, and validation split 0 0.1. Batch size 10. X size is 360, Y size is 100. X test, Y test, test loss. Okay, now run this. Y train equal to scalar fit transform. Y train equal to scalar fit transform. Okay, so here x train x test, again run. Now again run this one as well. Now try this one. Okay, now it's working fine. So keep an eye on the validation loss to ensure your model generalize well without overfitting. So test loss is 508.91. Okay, so preventing overfitting with dropouts. So we can use dropout layers which randomly deactivate a portion of neurons during training. So for this we need to regularize our neural network. So for this model underscore regularized equal to sequential. Okay, so the first one is dense 64. Now the input dim equal to x train dot shape, which is 1, and activation method is reload. So I press the tab, and now here we use the dropout, which is 0 0.3. Now compile and train the regularized model. So for this model underscore regularized dot compile optimizer Adam learning rate, which is 0 0.01, and loss mean squared error. Okay, now after this fit the data model regularized, and x train, y train, epochs 50, validation split 0 0.1, batch size equal to 10, and verbose equal to 1. Now, so here a 30% dropout rate is often a good starting point to reduce overfitting, but always experiment to find the best value. Now I am running this code. Again getting an error. Okay, here we miss the comma. Now run. X train is not defined where we are. This underscore. Okay, so here you can see the loss is 238.0523. So today's we explored building and optimizing neural network for regression tasks, from data normalization to regularization with dropout. So these are essential techniques to master. Okay, so data normalization is crucial for faster training and stable convergence. And the second one is the model evaluation. Use mean squared error for regression tasks to measure performance. And the third one is the dropout layers, which prevent overfitting by randomly deactivating neurons. So don't forget to like, subscribe, and hit the bell icon for more practical deep learning tutorials. See you next time.